Okay, so 2D pathing. Now, with that said, okay, I did hit record. You're the A star system will always kind of top this, right? It's I mean, this system works, and it can be very useful in a lot of cases. It's not as heavy as the A star, but I mean, if you don't want to set up A star, you really don't need it, because it's, you know, you're just doing some more of basic stuff. Then a system like this will actually work just fine. Actually, I got to move him really quick right now. I got to slow him down. All right, because he's not supposed to be going through that stuff. But I have his movement kind of weird right now, just to show something. So the player is literally nothing. He's just something I'm dragging around. Everything's on this little AI guy. So that's just his movement there. And that was a target system. But everything's happening here. That's all the logic, right? So what I'm going to do is I'm going to remove that. It's gone. Our AI is now literally just a stupid little sprite. So what we need is, let's make a sentry system. So ideally, what I'm going to do is I'm actually going to build an array of directions. Okay. Now, because I don't know them off by heart. For example, let's try something here. No, screw it. It's just easier if we just tell it to normalize. Okay, so we have, say, 8 directions that we can move in. Right? So looking at our AI, we want to check everything around them. So let's, now we could try to sphere cast and just collect everything and go from there, but this is almost just kind of easier. So let's start with left. Okay, that's left. We're shooting left. We also want to go left and up. Well, you know what? This should be vector 2s, I think. One sec. Raycast 2D. Yeah, it takes a vector 2. All right, so let's turn these to vector 2s. Sorry. So we have left, then we have left and up. We have up, right? So now we have this way, this way, this way. So now we need up and right, going that way. We need right, that way. Now we need down and right. We need down and left, right? Because now I'm this way, and then left is back up here. So there's our 8 directions in an array. Okay, I'll remove that. We don't need that. The other thing I want is another array called, we'll just call this blocked. And you could also use floats and run weights and stuff, but to keep this simple, we're going to just do that. Right, so what do we need to do? Let's start over here. Let's make this our detection right here. Array get next. So we are going to go through our directions, and we're going to loop. And we're going to have a done event. And this is going to be our current direction. And we also need the current index. Okay. So we're going to loop, and we're going to have it done. So on the loop, what do we want to do? We just want to raycast. Okay. So we're going to raycast from our current direction. So we're going to raycast through each of those. Space, self, you can do world. I mean, it's a 2D game. I mean, Y up is going to be Y up. Distance, you don't need that much distance. Maybe 1.5. And if we hit, we could have a hit event. So what does that look like? We have a hit event, but then unless there's a Raycast 2D2, which I don't know if there is on the ecosystem, there might be, we're just going to use the next frame event. Or you can also do an object compare, I guess. And we'll just call this next. Right, so if we hit something in whatever direction we're facing, we want to set array. We want to set our locked at the index of whatever index we're on here for our directions to a value of true. Right? And then we're just going to finish that and go back here and get the next direction. And if we don't hit something, then we want to go through this exact same thing, but we're going to set it false and then go back here. So now, all of a sudden we have this, we can iterate through our array and we find everything that's around us, and we're going to set an array of bools to tell us what's around us. All right, pretty simple so far. Running two arrays. Now, what do we want to do with this information? Well, first of all, the other thing we're also going to need is we're going to need some kind of target. Where do we want to go? All right. So once we have this stuff, we're going to use this again. I guess I can get rid of that. Done. So now we're going to go through the same. Actually, no, we don't want to do the directions. We want to do, well, you know what? No. I'm trying to think what would be the best way to do this. All right, so we've set all our blocks. And now let's get position 2D of our target, and that's going to be our target position. And let's get position again 2D of ourselves and our current position. And now we can do a vector 3 operator. And we're going to take our, vector 2 operator, not a vector 3. It's just so used to dealing with vector 3s. We're going to take our target position and our current position, and subtract those, and we end up with a desired direction. Now, we want to normalize this vector So desired direction, we're going to normalize it. Now let's just finish this so we don't get too confused here. So now we have a direction to where we want to go, right? Or where our target is. So now we want to array get next. So now we could probably use the directions, and we can use the same loop and the same done, and we could actually use that current direction. We can reuse that, and the current index. That's fine. Almost exactly as to that one. It's almost virtually the same. So on this loop, what do we want to do? We want to normalize this current direction. Actually, you know what? We should almost do that up here as well, just to make sure it's going in the right direction. Right, so we're gonna normalize this. Now what we can do is a vector to operator again, and we know we have what? I thought I grabbed the vector 2 operator. Why did I mess that up? Right, so we can take now our desired direction and this current direction, and we can do this thing called dot product, and it's going to return a float. Okay, so what it is if you have a vector, we'll say we're here and we're going this way, right? So we're going to the left. If we have another vector over here and it's going to the right, to compare this vector to this vector, they're going the exact opposite. You'll end up with a dot value of -1. But if this guy's going left as well, so they're both going the same direction, you'll get a dot value of 1. And if this guy's, say, going up or down, and this guy's going left, you'll get a dot value of 0. Right, so you get this kind of this dot value based on how they match, I guess you could say. So the other thing we want to do, so we're going to get this current dot, and once we have that dot, should almost do the blocks first. Yeah, we should probably do the blocks first, right? So we're going to get the direction, and then let's array get from the blocked at that same index is blocked, and then bool test. So more or less, we're going to grab all the directions, and we're going to check a direction, and if it's blocked, then we're going to skip this guy. We just flat out aren't even going to consider it. Right, so let's skip and go back here, get a different direction. If not, we'll go next. If they're not blocked, let's check. So we're going to get this now. Now we're going to get the dot. And once we got the dot, we also need another dot, or another float value. Set float value. We're going to stick this somewhere in here. And this is going to be the best dot. And it's going to be -1. That's what we're going to set, which is the exact opposite to where we want to go. That's perfect. Easy to beat. And set int value to best direction. and that can be 0. That's fine, not a big deal. So anyways, now we're going to go through and we have our current dot. So now we can float compare this current dot to the best dot. And if the best dot is, or well, if this guy is higher than him, then we have a new best dot. And if it's not, then we'll skip it. If it's equal, we can also skip it. So now we skip, and we have a new best. So skip, go back to the start. And if it's a new best though, now we have a set float value, and we have a set int value, right? So now we're going to set the best direction to the current index, because that's this guy. So that runs through all these tests, and if he happens to get this far, we want to keep this guy in memory. So that's kind of what this is. The float value is the best dot is now going to be, we're going to fill it with the current dot. Okay, so now that we've done that, we can finish, I believe, and go back. So when this is all done, it's gone through all this stuff, at the very end, we can now turn around and array get from the directions at the best direction and set this as direction. There we go. Right, and if we want to see this kind of in action, I'm just gonna loop this all together like that. I'm gonna stick a next frame in here so we don't fry everything. Right, and we're going to take this set as direction just so we can see it, and we're going to stick it out here. Okay. Raycast, and let's turn the Raycast debugging on so we can see what it looks like. Right, so he's raycasting, and we could probably extend that out. It's kind of short, but right now, obviously, we don't have a target. I suppose we need to get a target. So that's the other thing we need to do. What is our target? Well, our target is, let's name this so I can stop looking at new sprite. This is our player. And this is our enemy. So our enemy needs a target. Let's give him a target. So now our enemy all of a sudden has best direction is to the left, right? Which would make sense. And if we move him up, right, the direction's still left. But if we hit this, he's saying, no, we need to go left up. He wants to go this way, but this one's not hitting that beam, and if I block it, he was now saying go left down. Right, so you see how those rays are coming into play. So we need to extend these rays. So right now we are at 1.5. Let's double that and go 3. So now we have this direction. Now as we go through this direction, once we have our direction, let's and you could do this part in many different ways. You can have a constant move through another FSM or go through this same FSM. Now let's translate our owner to set this as direction. We can go world per second every frame. And let's now wait, because after 1 second, we should move far enough, and we can go back. I don't know why I put 2 weights in there. Right, now we might have to multiply this. Right, so we scan the direction, and we do our checks and we move. Scan our direction, do our checks and move. Scan our direction, do our checks and move. Right, now all of a sudden, if I bring him down here, he wants to come down and around. Right, so he's going to avoid all this stuff, and it doesn't matter if I try to move these things around, he'll react to it, right? But he wants to get to the player. And there's more to that we can add to it too, right? So we can, you could lerp him into these positions right to into like almost a grid-like fashion. You don't have to. I mean, it's just right now we have a direction, and that's the important thing. The only crappy thing with this system, and this is really where there's a big difference between just doing it this way and say using A star, is the A star actually makes a complete path, right? And then you can update that path. Where this guy, if I stick him here, this AI is just going to get screwed right up. Probably, maybe not. Right. So if we come over here, he wants to go that direction. Right, we can kind of screw him up by going back and forth, and maybe that's fine. I don't know. Maybe that's not that bad of a thing. But he's not going to be the smartest tool in the shed. Let's just put it that way. But he is following, and he is avoiding things, right? Now, with that said, if you wanted to do this more of a grid style, right? Let's just see how gridish we can make this. Let's set all those to that, to solid numbers. And if we go on, I guess the Z's should be 0 anyways. So 6, 7, 5. Right, so roughly 2.5, I think. Right, 5. 7.5 would be kind of 2.5. So with that said, if we wanted to say, instead of the translate, actually we already have his position, don't we? So let's vector to add we want to do that. Okay, we have our direction, so let's multiply. Vector to multiply. Set this as direction, multiply it by 2.5. Vector 3, our current position, add, set this, and now we're going to interpolate. Let's interpolate. Let's do that one. Let's interpolate linear from current position. Okay, so I'm not going to use the add because I don't want to wreck our position variable. So let's add and get rid of the weight. We're not going to need that right now. Current position, add our set this as direction, add those. We're going to get a final position Now we can interpolate our current position to final position over, say, 1 second. And store that as, we can even store that as current position. And then set position. Move that to the bottom. To current position, world, every frame. So when this is done, he can do finish. All right, and now we should get we have this kind of more of a grid style movement. With that said, obviously all these blocks would need to go on that same grid, or else you'll have this kind of overlap like that. Right? So to make that look better, you know what? Let's get rid of all those. Let's take this one, so we just have one. And 2.5 times 150. And let's take 2.5 times 200. 0. All right, so there's him. And now let's take that and add 2.5. I have grids. Let's turn that on. That should work. All right, so that needs to be changed, obviously. What? Oh, stupid thing. Of course, I'm playing around with so many things in here, right? All right, you know what? We don't need to play with. Where is it? Where's the plugins? That stuff. Get the hell out of here, game creator. No one frickin' likes you anymore. All of you, shoo. Shoo, game creator. Alright, get rid of that. Oh, apparently I was playing around with some scripts. Gotta delete those. There we go. Still have this bar apparently, but oh nope, it's gone. Get rid of that crap. Okay, so now we can take this and go 2.5. Alright, so now I can take this guy. It's weird how he's like that. Whatever. Not that worried about it. Now there we go, and let's go say upwards. And let's take one and go down here. Alright, so now let's take our player and enemy, bring them up over here, turn this crap off. Now that everything is kind of on this grid-like thing, he'll snap once, and he should. He's a little off, but and if I take this guy and put him on a higher sorting layer, at least he'll sit above. Yeah, see now he's screwed up right there. He doesn't know which way to go. He doesn't know how to get to the player now. And that's the downside of going with this style, is he only really sees what's there. So you have a big maze style level and stuff like that, it's really not the best thing per se. But again, it really depends on the game. But if it's not the most complex collisions, it works fine, right? Like, it's out in the open, you have some obstacles, it's not the end of the world, he will avoid them just fine, right? And that's with that, and you can speed that up, right? Like, it's you loop through all that, right? And you could, I don't know, 0.15. You know, so there's various things you can do. And that's only if you have the direction here. You don't even have to have the actual movement here. You can put it in another FSM and constantly be moving towards it, and then have it just kind of call and ask to get a new direction once in a while whenever it needs it, like every, you know, 1 unit distance kind of idea, but then have it kind of slowly constantly moving. But that's kind of how we can do some more basic 2D pathfinding that doesn't really involve baking any kind of nav mesh. You're not using A stars. It's not the greatest pathing system, obviously, in the world, but it's not bad. It's not bad. It's not the most complex thing. It's not that hard. Due to all the rays, I mean, you may not want to run too many of these things, but at the same time, I mean, if you had a nav mesh, every time you try to calculate a path on a nav mesh, you have to run under the hood. There's a pile of rays that have to run because it runs through all the different nodes and points as it tries to calculate a path, right? So I mean, really, when you look at this, and it kind of maybe looks scary that you have these 8 Raycasts firing, those 8 Raycasts are going to be less than calculating a nav mesh path. But there we have some 2D pathfinding, right? And that's, like I said, that's just one simple movement style. I should almost do a video sometime, maybe on the A star and how you'd link that up. But that's all it is. It's just some arrays. So, sounds good. Talk to you guys later.